video, we're going to use the factor theorem to solve a polynomial equation. It says for what values of x is x cubed plus 7x squared minus 36 equal to 0 a true statement? List the values separated by commas. So to solve this, basically to figure out the factors, we're going to need to find at least one factor so we can do a division. To find that one factor, we're going to use what's called the rational zeros test. And the rational zeros test is pretty simple. You take the ending factor, which we're going to call this p, and we're going to take the leading coefficient, which we'll call q, and we're going to write out all the different possible factors of each of those. So for p, you've got plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4. 5 doesn't work, 6 does, plus and minus 6. 9 works, 7 and 8 do not work, so plus and minus 9, plus and minus 12, plus and minus 18, and plus and minus 36. Those are all the factors of p. And then the factors of q would be plus and minus 1, because the leading coefficient is 1. So then you take p divided by q, and you write out all the possible factors. So when you write out all the possible factors of p over q, you basically just take this plus and minus 1 divided by plus and minus 1, plus and minus 2 divided by plus and minus 1, so on and so forth. Well, when you divide all these, you're dividing by 1, so you're just going to get really what p was. So we're going to say all factors of p. Now sometimes if your leading coefficient is 2 or 3 or 4, you would have plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4. And then you'd have to divide each of these p values by each q value, so you'll get a bunch of different factors that could possibly work. So how do you use the rational zeros test? Once we go through and find the factors, which would be all the factors of p, we just start plugging them into the equation until we find one that equals 0. I'd suggest using some sort of graphing calculator. Definitely help this, make this be a lot easier process. So we're going to type in x cubed plus 7x squared. X squared minus 36. And then I'm going to store positive 1 as x, and then put it in that equation. I get negative 28. So that didn't work out. I didn't get a 0, so now I'm going to use negative 1. I'm going to store it as x. Grab this equation. I get negative 30. So positive 1 and negative 1 don't work. Now I'm going to plug in positive 2 and negative 2. So 2 stored as x. I get 0. So that means that 2 is a 0 for the function. So I'm going to write out here that one of my zeros, we're going to call it x equal 2. And then I'm going to go ahead and get the factor real quick. That would be x minus 2. If I subtract that over, x minus 2 equals 0. Remember, we're looking at this at the end of the zero product property. So once I get this factor, I'm going to then divide this polynomial by this factor, or this 0 of 2. So I'm going to do synthetic division, write 2 there, write out all the coefficients for x cubed, which is 1, x squared, which is 7. I don't have an x term, I better put a 0 to have a placeholder there, then negative 36. Drag the 1 down, 1 times 2 is 2, add that, that would be 9, multiply, that's 18, add, you get 18, multiply, you get 36, and you end with 0. So your remainder here is 0. Your constant here is 18. This is your x value, this is your x squared value. So you have x squared plus 9x plus 18. That's really being multiplied by this term x minus 2, because that's what we divided. And this is the original function, x cubed plus 7x squared minus 36. Let's go ahead and use ZPP here, but we're going to ignore this x minus 2 term. And that would be x squared plus 9x plus 18 equals 0. Remember, ZPP is zero product property. We can factor 18 to x plus 6, x plus 3 equals 0. And let's see, they want all the, for what values of x, so they want us to solve this. So we're going to go ahead and use ZPP again. So that's x plus 6 equals 0, or x plus 3 equals 0. So subtract the 6, you get x equal negative 6, or x equal negative 3. So our x values would be 2, negative 3, negative 6. All of those are zeros for the function.